Hello everyone, myself Anasha. So today we are going to discuss a topic named divergence and curl. So let us start with divergence. The divergence of a vector field f bar is denoted by divergence of f bar or del dot f bar. So here it is dot product and is defined as divergence of f bar is equals to del dot f bar. Now we know what is our del. Del by del x I cap plus del by del y j cap plus del by del z k cap dot f bar. Now we assume our f bar as f1 I cap plus f2 j cap plus f3 k cap. Put this over here and do the dot product. So if I do the dot product, divergence of f bar will be equals to del f1 upon del x plus del f2 upon del y plus del f3 upon del z. So what you have to do, just do the partial derivative of f1 with respect to x, f2 with respect to y and f3 with respect to z and add those three quantities. So you will obtain divergence of f bar, which is a scalar quantity. Now, a point in a vector field f bar. So if you consider a point P in a vector field f bar, it is known as a source if divergence of f bar is greater than 0, and it is known as a sink if divergence of f bar is less than 0. Now, if divergence of f bar is equals to 0 at all the points of the function, then our vector field f bar is known as what? Solenoidal. Most important definition, right? So here we have studied totally three things. If divergence of f bar is greater than 0 at point P, right? Then this P is known as source. If divergence of f bar is less than 0, then it is known as sink. Now, if divergence of f bar is equals to 0 at all points, right, then the f bar is what? Solenoidal vector field. Okay. Next, let us study few examples of divergence. So we have to determine whether the given vector field is solenoidal at point 1, 2, 1 or not. So in order to determine whether it is solenoidal or not, we have to first find divergence of f bar. Formula is del f1 by del x plus del f2 by del y plus del f3 by del z. Compare our f bar with f1 I cap plus f2 j cap plus f3 k cap. So our value of f1 is what? Y square, f2 is 2xy and f3 is what? Minus z square. Do the derivative of f1 with respect to x. Here there is no x, so answer will be 0. Plus do the derivative of this term with respect to y. So it will be 2x plus do the partial derivative of f3 with respect to z. It will be minus 2z. Right, now we have to put the point 1 to 1. So divergence of f bar at point 1 to 1. So your value of x is 1, y is 2, z is also 1. So now put this value in this. So answer will be what? 2 minus 2, that is 0. So divergence of f bar is equals to 0 at point P. Therefore, we can say that vector field f bar is what? Solenoidal. Okay. Now let us solve one more example. We have to find the value of lambda for the vector field f bar, right? Provided this vector field is what? Solenoidal. So you are given that this vector field is solenoidal. So what we can write? The divergence of f bar is equals to 0, right? Because we are given that f bar is solenoidal. Okay. Now we know the formula of divergence of f bar. It is del f1 upon del x plus del f2 upon del y plus del f3 upon del z. This is equals to 0. Now you can see our f1 is what? 2x square y square plus z square. f2 is 3x y cube minus x square z and f3 is lambda x y square z plus xy. Let us write the answers of the derivative. So del f1 by del x will be 4xy square. Okay, plus del f2 upon del y will be 9xy square, right? Plus del f3 by del z is equals to lambda xy square. Okay, this is equals to 0. Now we will get answer as 13xy square plus lambda xy square is equals to 0. Now you can simplify this. So lambda xy square is equals to minus 13xy square. So these two gets cancelled out. So final value of lambda is what? Minus 13. So this is our required answer. Next, let us study the definition of curl. So the curl of vector field f bar is denoted by curl f bar or del cross f bar and is defined as del cross f bar is equals to del by del x I cap plus del by del y j cap plus del by del z k cap cross. Or f bar is what? f1 I cap plus f2 j cap plus f3 k cap. Now whenever you want to do cross product, what you have to put I cap, j cap, k cap. Now put these quantities, that is del by del x, del by del y plus and del by del z. From here put f1, f2, f3. Now solve this determinant and obtain the answer. So the curl of vector field will be a vector quantity. Okay. Now if the curl of f bar is 0 bar, right? Then we can say that the vector field f bar is what? Irrotational at all points of the function. Otherwise it is said to be rotational. So what we have studied over here, if curl of f bar is equals to 0 bar, then the vector field f bar is irrotational, right? And if this is not equal to 0, then f bar is rotational vector field. Okay, so now let us solve few examples of curl, right? Now in this we have to find divergence as well as curl of vector field v bar, that is xyz into xi cap plus yj cap plus z k cap. This is our vector only. So let us write our vector v bar as xyz into xi cap plus yj cap plus z k cap. This vector can be written in this form also. Now simplify this. So it is x square yz I cap plus xy square z j cap plus xyz square k cap. Now firstly let us find the divergence of v bar. So the formula is del v1 upon del x plus del v2 upon del y plus del v3 upon del z. This is your v1, this is your v2, this is your v3. So it will be 2xy z plus, again if I do the derivative of this, it will be 2xyz and last derivative will also be 2xyz. So the final answer of divergence of v bar is 6xyz. Okay, so now let us find the curl of v bar. So curl of v bar is equals to del cross v bar and the formula is ijk del by del x, del by del y, del by del z, and v1, v2, v3. Now we know the values of v1, v2, and v3. So let us put that I, j, k. Del by del x, del by del y, del by del z. Or v1 is x square yz, v2 is xy square z, and lastly v3 is xy z square. Okay, so now let us find the value of the determinant. So I cap and bracket minus j cap, you have to solve and put it over here, plus k cap and the answer. So if I solve from here, it will be del by del y of xyz square minus del by del z of xy square z. Fine. Similarly, if I solve from here, it will be del by del x of xyz square minus del by del z of x square yz. And lastly, if I solve from here, it will be del by del x of xy square z minus del by del y of x square yz. So now just write the answers of the derivative. If I solve with respect to y, it will be xz square minus, if I solve with respect to z, minus xy square. Now solve again over here, it will be yz square minus x square y and plus k cap times. Last answer we have to derive by finding the derivatives over here. So it will be y square z minus x square z. So this is your answer of curl, right? So now let us go to the next example. We have to show that this vector field is both solenoidal and irrotational. So firstly we will show that the vector field is solenoidal. So we will prove that the divergence of f bar is equals to 0. So let us write the formula of divergence of f bar. It will be del f1 upon del x plus del f2 upon del y plus del f3 upon del z. Now this is your f1, this is your f2 and this is your f3. Just put the values of the derivative. So del f1 upon del x will be equals to minus 2, right? Plus del f2 upon del y. From here just do the derivative with respect to y. So it will be plus 2x. And lastly del f3 upon del z will be equals to minus 2x plus 2. Okay, now you can see these two gets cancelled out and also these two gets cancelled out. So final answer of divergence of f bar is equals to 0. Therefore our vector field f bar is what? Solenoidal. Okay, now let us check whether it is irrotational or not. So we will find curl of f bar, that is del cross f bar. So the formula is I cap, j cap, k cap, del by del x, del by del y, del by del z, f1, f2 and f3. So put the values of f1, f2 and f3. So I, j, k, del by del x, del by del y, del by del z. Your f1 is y square minus z square plus 3yz minus 2x. Your f2 is 3xz plus 2xy. And last value of f3 is 3xy minus 2xz plus 2z, right? Now we just have to solve the determinant. So now we have to find the partial derivative of this with respect to y. So answer will be what? 3x. Okay. Now if I solve over here, you have to write the answer of the partial derivative with respect to z. So answer will be minus 3x. Similarly, let us solve from here. So you have to solve these two, right? That is, you have to find the partial derivative of this function with respect to x. So answer will be 3y minus 2z. Now minus, and now find the partial derivative of this function with respect to z. So answer will be minus 2z, okay, and plus 3y, okay. And lastly we have to solve from here. So it will be 3z plus 2y minus, now solve from here. So we have to do the partial derivative of this with respect to y. So it will be 2y plus 3z again. So now you can see from here we are getting 0 I cap. If I open this bracket, we will get plus 0 j cap. This also everything gets cancelled out. So plus 0 k cap. So this is vector 0 bar. So from this we can say that curl of f bar is equals to 0 bar. Therefore our vector field f bar is what? Irrotational. Okay. So today we have studied total 2 topics. One is divergence and other is curl. So if you are given a vector field f bar that is equals to f1 I cap plus f2 j cap plus f3 k cap, then divergence of f bar is given by del f1 upon del x plus del f2 upon del y plus del f3 upon del z. Now from this we have studied if divergence of f bar is greater than 0 at any point p, then p is known as source. If divergence of f bar is less than 0, then point p is known as sink. And if at all points divergence of f bar is equals to 0, then f bar is known as solenoidal vector field. Okay. Now we have studied the next definition of curl. So if you are given a vector field f bar, curl of f bar is defined as del cross f bar, and that is equals to I cap, j cap, k cap, del by del x, del by del y, del by del z, f1, f2, f3. Right? You have to solve this determinant and find the answer. Now if curl of f bar is equals to 0 bar, then f bar is what? Irrotational vector field. Otherwise we call rotational vector field if this curl is not equal to 0. Right? So this divergence is a scalar quantity, right? And this curl is a vector quantity. Fine. So I hope you have understood throughout the session. Thank you for watching.